Hello, can you hear me? Can you hear me now?
Yes.
All right. So we continue from where we stopped. In the previous session, I introduced you to empirical rule and Chebyshev theory, and then I explained the principle behind these two theories. Now we are solving this question, and we have already solved part A. Now let us solve part B. Remember, the question says, assume that the average age of an MBA student is 31.6 years, and that the standard deviation is 2.8 years. Now it says we have done part A, so let's look at part B. Part B says, using empirical rule, determine the range of ages that will include 99.7% of the students around the mean. Okay, so let's do that. That means I think I'm going to move this down so we can have enough room for this. Move it down a little bit so we have enough room. Yeah. All right. So that page, so that have more room. Okay, good. Have more room. Now part B. So B part says B. Again, our mean is at 1.6 and the standard deviation is again 2.8. So we don't have to we have them from the question. Now it says using empirical rule, what determine the range of ages that we include 99.7% of the students around the mean. Now, according to Chebyshev theorem, we go to the theorem where I explained it. It says that empirical rule, empirical rule say that about 99.7% of all values fall within 3 standard deviations. So that means we're going to use the formula for 3 standard deviation, and that is right here. I'm going to remove this. Okay, I have on the left side mean minus 3 standard deviation. As for the lower side, on the right side we have mean plus 3 standard. So it's the same thing, except that in the left side you use minus, on the right side you use plus. Another way of saying it is that for the lower side you use minus, and for the upper side you use plus. So let's go down and use it so we can get the answer to that part, which means that for 99.7% of the mean, sorry, 99% use this following. We'll have mean. I'm gonna click on the wrong thing. I'm gonna close it. So it says use mean, okay, minus 2 standard deviation for the lower parts, lower range. Okay, lower range. Okay. So mean minus 2 standard deviation minus 3 times standard deviation. And with that, we apply that. We're going to have our mean is at 1.6. At 1.6 is our mean. So we got it right here at 1.6 minus 2 times standard, 3. This time we're using 3 because it's say 99.7. And our standard deviation is 2.8. That gives us, if we plug this, I'm going to write this on paper so we can get the answer from the calculator. 3 times 2.8. So going to our calculator, we have it in this form. Clear all this. So I have mean of 31.6. Okay, 31.6 at 1.6 right here. 0.6 minus 3 times standard deviation of 2.8. We got 2.8. 0.8. Okay, and that gives us this answer that we see on the right side, 23.2. I'm gonna write it down, 23.2. And if you do the plus side of it, let's just do the plus side and go over and put it in. Plus, use the plus sign, we're gonna get 40 that we have here. You can see the 40 right here on my right side. If it is plus, so I'm gonna go and put them in. We go by there on our paper. So I'll move this to that side. So for this one, we got 23.2. Then if we repeat this for the same thing for the upper range, okay, you have the upper range. The upper range. This time around, we're using the plus sign. And from what we got from our calculator, we got 40. What we got from the calculator. So now completing that, we said using empirical, determine the range of ages that will lie between 99.7% of the students around the mean is this ranges will be right this way. That's our conclusion. The range of values, okay, that will include 99.7% of the students around the mean will be equal to 23.2 years, okay, to 40 years. Any question on this one? Any question? I'm sure that's excellent. That's very good. Now, that is this one. Then let's look at the one that involves Chebyshev's theorem. It says here, using Chebyshev's theorem, determine the range of ages that we include at least 94% of students around the mean. Now, for Chebyshev, it says here, if you go up a little bit, Chebyshev says that say that at least 94% of data values must fall within 4 standard deviation of the mean. And that's what, I mean, that's what he said, that 94% will fall within 4 standard deviation of the mean, according to our Chebyshev theorem. So we use that, instead of 3 now, we use 4. That would basically give us what we are looking for. So again, going back to our question, our mean is still it's over here. Our mean is still at 1.6, and the standard deviation is still 2.8, because it is the same question we are solving. And this time we're doing part C, and part C involves Chebyshev. So according to Chebyshev, is 4 standard deviation. So we repeat the same thing. It says here, to using Chebyshev to determine the range of ages that we include 94% of the student around the mean. So we have the lower sides, okay, lower, okay, will be our mean minus 4 times standard deviation, because according to what Chebyshev says. So we have our mean is at 1.6 minus 4 times standard deviation of 2.8, okay, of 2.8, okay. So going to our calculator, we can get this answer to this. So let me write it down. We got that 1.6 minus 4 times standard deviation of 2.8. Now, what we gotta do is to go to our calculator and change this to first standard deviation and minus sign. See, minus sign, and change this 3 to 4. I mean, it's 4 times standard deviation, and it give us the answer 20.4. We got 20.4. So we go and put it right in 20.4. That puts right in our workbook. 20.4. Okay, 20.4. Now we'll repeat the same thing for the upper side, but this time around we use a plus sign, and then we get our for the upper side. We use plus sign for this one, and plus sign here. So we go to our calculator to see the answer it will give us. So this is our calculator right here. I have changed this to plus sign. Plus sign, see, 42.8. So that's 42.8. But it's plus 42.8. And that take care of that. We got 42.8. So that the range the range of values, the range that will include 94% of the students around the mean will be, okay, according to our calculations, the range of values that will include 94% of the students will be 20.4 years. 20.4 years. To for the 2 points are 8 years. Questions on this?
No questions, but can you keep the screen right there for a second?
Sure. Got it?
Yeah.
No.
You didn't? Take a photo. Take a photo of it.
I got it.
Okay, got it. Okay, good. Now, the last question on that section, which we conclude our data description, is using Chebyshev theorem to determine the range of ages that will include at least 80% of the students. Now, if you look at the Chebyshev theorem, it does not have give us the how many percentage of data values that will lie within 80%. I mean, he give us for 75%, for 89%, and for 94%, but he didn't give us anything for 80%. So what we're gonna do here is that we're gonna estimate it. We're gonna estimate it using the this formula of Chebyshev, this one here. What is it? What is it? Somewhere. We're gonna use it to estimate it. Right here, we're gonna use this formula to estimate it because it is not here. So we can we have 35%, 89%, 94. These are the ones that are set on stone, you know. But this one, 80% is not there. So we gotta estimate it using this formula that I just copied. I'm gonna paste the formula so we can apply it to this question, part D. So part D, we can make the estimate. That will take a little while, but it's what it is worth the time. We estimate using the formula. The formula. Okay, let me put it this way. It says find the data values that will contain. Determine the range of ages that we include at least 80% of the students around the mean. So our mean is still the same. So we have it as here, and we still have the same standard deviation. Okay. But the problem is that we don't know what K is. See, we don't know what K is because it says how many standard. Let me explain what I mean by that. If you go back to what Chebyshev stated. Say light, 75% lie within 2 standard deviations. 89% lie within 3 standard deviations. So in each case, 2 is the care, 3 is the care, 4 is the care. But since we don't have the 80%, we don't even know the care. So the first thing we do is to estimate what our care will be. With that, we can estimate the number that lie within fall within 80% of the values. So now let's estimate the care by using this formula here. It says 80%. Okay. So we have the formula. Let me write it the way I'll put it this way. Care squared. I'll take you to play matter of fact. Yeah, let me take you to a workbook that will allow us to put this formula in this form. So that becomes this one here. We have care 1 minus 1 over care. I'll move this down a little bit. So have it in that form. Okay. Have 1 minus 1 over care squared. 1 over care. We're talking about care squared this time around. So have care squared. Okay. Times well, because you say 80%, they already have the percentage, so I'm gonna put just equals 80% is 0.8, within 80%. So I'm gonna copy it. So with this equation, we can get the value of our care. We can solve it to get the value of our care. Then after that, we can now use it to find the value we are looking for. So this is the equation we use, see? So to get our care. So solving this using a equation, we have that care. Okay, we have that 1 minus, why is it doing this? Okay, let me see. Oh, we're close to it. Well, it shouldn't be doing it. Let me delete this and so I can. Okay, let me start from here again. Have okay, this unbelievable. Okay, we have 1 minus 1 over care squared. Okay, equals 0.8. But if I want to use computer to type this in, it will take us a long time. I'm gonna use the eraser to delete this. Okay, I'm gonna go back 0. Okay, 0.8. Okay. Now I'm going to move this down so we can have enough room to solve this simple equation. Yeah. Now,
what did you get at 0.8? What did you get at 0.8?
Because it says 80%. 80% is 0.8.
Oh, got it.
Yeah. So that we have if we remove this parenthesis here, if you take it off, we're gonna have this 1 minus 1 over care squared. Okay, equals 0.8. Oh, excuse me. My hand okay, equals 0.8. We have 0.8. So now solving this, okay, we we have, first of all, we need to remove 1 from both sides. So to make this one stand by itself, you remember your algebra. So remove this to make this one stand by itself. So we need the 1 over k squared stand by itself. So we're gonna do minus 1, and anything you do on the left side, you must do on the right side. Minus 1, and then you draw a line. So this is gone. 1 and 1, 1 minus 1 is gone. So we have negative or minus 1 over k squared. Okay. Equals. Now we need to get 0.8 minus 1. So we can get that from our calculator. We have clear this. So 0.8 minus 1 give us this answer here, negative 0.2. You can see right here, negative 0.2 on the right side, extreme right, negative 0.2. So we go in and put negative 0.2. Remember, all this is just to get the k. Negative 0.2. Okay. So now, again, solving for this case. So now at this point, I will need to make the k squared to, find out a way to make k squared stand by itself. So what we need to do now is to make it, I would say, there's a lot of exponents. Let's make it positive first, then we can get that. Yeah. So to make this positive, I will divide by negative 1 on both sides. Okay, we have negative 1. Okay, negative 1 to make it positive. So you have 1 over k squared, because now negative sign is gone. Negative divided by negative is positive. Okay. Okay, equals negative 1 divided by negative 0.2 give us 0.2. Okay, 0.2. Now, by law of exponents, k squared now will become, if you flip it up, if you flip it now, if you flip this one, and that'll give us some 0.1 over 0.2. Okay. Or another way you can get this done, you can say to get rid of the fraction by multiplying both sides with k squared. So I think you can do that. I think that will give us a better idea. So to get it from, you can multiply this by k squared, multiply this by k squared. So to get rid of the fraction, so you have k squared. Okay, times this equals, anything you do on the left side, you must do on the right side. 0.2 times k squared. Okay, so that this one cancel out this one. This k squared here cancel out this k squared. So we have that. This one, this cancel out this, we have only 1 here. 1 equals 0.2. You know what? Let me bring it down so that we can have enough room. Okay, we'll have this. The computer is freezing up. Here is that. Okay. Now let me bring it down. When you divide this cancel out this one, you have 1 left. I'm gonna make it 1 left. So have 1 here equals, you have k squared times 2 times 0.2. That'll give us 0.2 k squared. Okay, k squared. Now, to make k squared stand by itself, divide both sides by 0.2. I'm gonna email you this video so you can always watch it. Divided by 0.2. I'm gonna put it and post it on Canvas. 0.2. So when you do that, you're gonna get this. So 0.2 cancel out. This 0.2 cancel out. So that you have only k squared left on these sides. Okay. Now, on the right side, you have 1 divided by 0.2 that you can get from the calculator. You have it here as, okay, clear this. 1, okay. 1 divided by 0.2, 0.2. And that will give us the answer of 5. You can see the 5 at the extreme right. So we'll go there and put 5. 5 right here. So, okay, 5. Okay. Finally, k squared is 5. To find the value of k, if you have k squared, to find the value of k, you use the square root of k squared. And anything you do on the right side, you must do on the left side. Square root of 5. And that'll give us the value of our k. K equals, now, find the square root of 5. You can get that from the our calculator. Square root of 5. Clear this. So this is square root of 5. Square root of 5. That gives us 2.236. We use 2.236. If you run this, it gives us 2.24. 2.24. So that the square root of 5 is 2.24. So you gotta be okay, 2.24. That's our k. 2.24. Now we find our k. Now we can now be able to answer that question. Remember, you were asking us to find using Chebyshev theory to determine the range of values of ages that will include 80%. So that's why we are doing all these estimates. So we can now use the 80% is closer. Since we have our k already as 2.24, we can use that to determine this. So we have that the lower range equals mean minus mean minus. Now answer for k is 2.24. 2.24 times standard deviation of the mean. Okay, which means our mean, if you remember, for this question, our mean is at 1.6. Okay, at 1.6, put at 1.6. 31.6 minus 2.24 times the standard deviation. And what is our standard deviation for this question? The standard deviation for this question is 2.8. 2.8. So go and put 2.8 for that place. 2.8. Plugging this into the our calculator, I'm gonna put it in a calculator so you can see what the answer looks like. So we have our, okay, clearing this, we have 31.6. Okay, 31, 0.6 minus, we got 2.24, 0.24 minus, I'm sorry, times 2.8, 2.8. And that will give us from the here, I can say 25.3. So we go over there and write 25.3 for that one. 25.3, which you can see from here. 25.3. It's 5.3. Now we can get our upper range. Repeating the process, but this time around we use plus sign. And this one going to be upper range. Okay, mean, but this time we are using plus sign. So you can put plus here. That means you can put plus here. And then let's see the answer it gives us from the calculator. What we gotta do is just go there and change the plus sign, the minus sign to the plus sign. Change this to plus sign. It was 37.9 years. Okay, 37.9 years. 37.9 years. So that's according to what the question want to know, it says the range of ages. So that means they determine the range of ages so that, put it right, that contain 80% of the students will be, let's see right here. Okay, the range of ages. Remove this. The range of ages that includes 80% of the students. Okay, we have 25.3 years to 37.9 years. 37.9 years. Question for me? Any query? Okay, since excellent. Now, since there's no question, I'm going to time. We can't achieve much. We have 6 minutes left. We can't achieve much in that. So I'm going to time us out. Now, please wait for 10 minutes. Log back in so that we finish. We do the last session, which should be a new topic. This one is this session concludes our data description. The description of this as it relates to this class. Next session will be our last session for tonight, and in that session we're going to begin the theory of probability. So see you in 10 minutes. Don't forget to log back in after 10 minutes using the same link that I gave you. Okay.
I have a question.
Yeah, go ahead, sir.
I mean, is it not preferable to use the mean plus like the standard deviation than to go around with the 1 minus 1 over k, something like that, times 100%?
So is it not better to use what the mean for?
I mean,
what?
like the first formula we use to get the A and B, to get the B and C, I believe, than to use this one.
The one we use to get the B and C, you use them because already it's the same formula, but already they have you know the value of the K. B says 99.7%. In that case, empirical rule have already told you that for 99%, 99.7% has 3 standard deviation. That is the K right there. And then now, for the other one, which is C, which says to use Chebyshev for 94%. Chebyshev rule have already told you that for 94% has how many standard deviation? How many? What is the K? 4 standard deviation. You can see right here. But this question give us 80%, right?
Yeah.
See, 80%. What is it? Right here, 80%. Now, Chebyshev theorem and empirical rule does. Chebyshev theorem have nothing for 80%. See?
Oh, I see.
So you have to, that means you don't have any care. So you have to estimate the care. And to estimate that care, you have to go this route that we just went through. Using this formula here, starting from this point, you just, to solve this equation, solve for care in this equation, that's all. You solve it to get your care, then you use that care for the upper range and for the lower range. That's it.
Okay. Thank you.
I got a question for you, Professor.
Yeah, go ahead, sir.
So the Chebyshev, is that how you say it? The Chebyshev?
Yeah, Chebyshev, yes.
Yeah, that so when you use that formula to estimate, say in the empirical formula or theorem, say in that one, and you have to estimate too, could you estimate in that one too? Or
yeah, but if you use empirical rule if the question said that distribution is symmetric.
Oh, okay.
If it's not symmetric, then you can't use empirical rule. If you look at the question we just solved, we used empirical rule here in this part B, because it says it tells you to use empirical rule. See?
Right.
Otherwise, if it didn't say use empirical rule for this, if you don't, this question did not tell us whether it is symmetric or not. So if assuming that it remove this part, that means you're gonna use Chebyshev because it didn't tell you whether it is normal or not. See?
Yeah.
That's why it says use empirical rule, because it didn't tell you that whether it's normal. Empirical rule can only be used for symmetric distribution, but Chebyshev can be used for any. Now look at the one we did before that. It says, and say that for a symmetric bell-shaped distribution, this one's mentioned that it's symmetric. So that will automatically know, you automatically know that you're gonna use empirical rule. Okay?
Yeah, I got you.
All right. So we have less than 3 minutes. Actually, now it is less than 2 minutes. So let me time us out. Please log back in 10 minutes from now. Let's finish up for the night. Okay? And I will see you in 10 minutes. After that, we can now take your attendance. See you soon.